Welcome to ANMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 8.1. Number 1. The mud deposited on the riverbed makes the river that runs through a village shallow. This makes the boat traveling in and out difficult. A boat that moves along the jetty in a straight line with displacement s meter t second after passing the jetty is given by s equals to t squared minus 4t. A. Copy and complete the table below. So we are given the time and displacement. We are looking for the displacement. So sub in the time into the function s equals to t squared minus 4t. So we get -3, -4, -3, 0, and 5. B. Sketch the displacement time graph to show the position of the boat. So from the function s equals to t squared minus 4t, we know with the positive t squared, we will have a smiley graph. So with the smiley graph, get the s when t equals to 0, we'll get 0 minus 0 and s equals to 0. So we will start from origin, and then when t equals to 1, we'll get -3, 2 will get -4, and this is the the minimum point up to -3 again, and 0, and then goes to 5. So here is our complete displacement time graph. C. Find the time in seconds when the boat is at the jetty again. So when the boat is at the jetty again, the displacement is equals to 0. So when s equals to 0 again, it will happen on t equals to 4. So 4 seconds later, the boat is at the jetty again. Number 2. Shaza cycles her 3-wheel bicycle in a straight line at her house backyard and has an initial displacement of 2 meters from a flower pot. Her displacement s meter t seconds after passing the flower pot is given by s equals to t cubed plus 2t plus c. A. Determine the value of c. So c is basically we can get from the initial displacement. So when t equals to 0, our s is 2 meter. So 0 plus 0, so c is basically equals to 2. B. Find the distance of Shaza from the flower pots when t equals to 2 and t equals to 3. So we have a full function of s of the displacement, s equals to t cubed plus 2t plus 2. So when t equals to 2, we have s equals to 2 cubed plus 2 times 2 plus 2, and s equals to 14 meter. Number 2. When t equals to 3, again, s equals to 3 cubed plus 2 times of 3 plus 2. So we have 35 meter. Question number 3. A particle moves along a straight line from a fixed point O. Its displacement s meter t second after passing through O is given by s equals to 3t squared plus 2t. Calculate the instantaneous displacement of the particle when t equals to 0 and t equals to 10. So we need the instantaneous displacement. When t equals to 0, so we just sub in t equals to 0 in the function of displacement. We get s equals to 3 times of 0 squared plus 2 times of 0, and we get 0. When t equals to 10, s equals to 3 times of 10 squared plus 2 times 10. So we get 320 meter. Question number 4. The diagram on the right shows a boy kicking a ball in a field. The ball moves in straight line and passes through a fixed point marked P. At t second after passing point P, the velocity of the ball is given by v equals to 7t minus 5. Find the instantaneous velocity in meter per second of the ball when t equals to 2 and t equals to 4. So we want to find the instantaneous velocity when t equals to 2, v equals to 7t minus 5. So v equals to 7 times 2 minus 5, and we get 9 meter per second. When t equals to 4, the instantaneous velocity will be 7 times 4 minus 5, which is 23 meter per second. Number 5. A particle moves along a straight line and passes through a fixed point O. Its acceleration a meter per second square at t seconds after passing through O is given by a equals to 4 minus 2t. A. Find the initial acceleration in meter per second square of the particle. So we need to find the initial acceleration. When we see the word initial, we know t equals to 0. So sub t equals to 0 into the function acceleration. So a equals to 4 minus 2 times of 0, which is 4 meter per second square. B. Determine the range of time in seconds when the velocity of the particle is decreasing. When the velocity of the particle is decreasing, means we are decelerating. So once we are decelerating, our a less than 0. So the 4 minus 2t less than 0, 2t greater than 4, therefore t greater than 2 seconds. Question number 6. A particle moves along a straight line and passes through a fixed point O. Its displacement s meter at t seconds after passing through point O is given by s equals to 2t squared plus t. Calculate A. The displacement in meter of the particle when t equals to 3. So this is very straightforward. We are given the function displacement. When t equals to 3, our displacement will be 2 times of 3 squared plus 3. There we get 21 meter. B. The total distance in meter traveled by the particle in the first 5 seconds. Since we have a quadratic function, so we'll build the table and see whether the particles turn. Alright? So we build the table from 0 to 5. There we start from s equals to 0 after we substitute 0 into t. And when t equals to 1, we get displacement 3 meter, 10 meter, 21 meter, 36 meter, and up to 5 seconds, we get 55 meter. So we know the particle is moving in one direction, okay, to the right. Therefore, the total distance traveled by the particle in the first 5 seconds is 55 minus the initial 0. Then we get 55 meter. Question number 7. A particle moves along a straight line at time t seconds after it starts moving. Its displacement s meter from fixed point O is given by s equals to the completely square of t minus 2 plus 5. A. Copy and complete the table below. So the time given is 0, 1, 2, 3, 4, 5, 6. And the displacement we need to find is substituting the t by 0, we get s equals to 9. T equals to 1, we get s equals to 6. When t equals to 2, we get 5. When t equals to 3, we get displacement equals to 6. T equals to 4, we get the displacement 9. T equals to 5, we get displacement 14. And when t equals to 6, we get the displacement 21. B. Sketch the displacement time graph for t from 0 to 6. So, from the function s equals to t minus 2 squared plus 5, we know we have a minimum point on 2, 5. Alright, so this is the basic knowledge that we already learned from completing the square. Alright, so with a minimum point on 2, 5, we have a smiley face. Alright, then from our table, 0 will get s equals to 9. So we'll get s-intercept equals to 9. And then when the t equals to 6, will comes up to 21. So here is our complete graph of s equals to the completely square of t minus 2 plus 5 from 0 to 6. C. Calculate the total distance in meter traveled by the particle in the first 6 seconds. So if we want the total distance traveled by the first 6 seconds, let's see. Alright. For the t from 0 to 2, we move from 9 meter away back to 2 back to 5 meter away. So it's actually traveled by 9 minus 5 meter, which is 4 meter. Correct? And the second part here is from 5 meter away, traveled to 21 meter away from the fixed point O. Therefore, we have 21 minus 5 plus on the second part. So the total distance will be 4 plus 16, which is 20 meter. Thank you.